Hi there, this is Katie with TutorPug, and I wanted to do a quick section on how to evaluate and interpret a definite integral. I actually tried to do this video yesterday and recorded the whole thing without sound. I don't know how, and have not been able to remedy that situation, so I'm just going to follow along with the work that I've already done. Also, I apologize for my voice. I've got a cold or something, so I sound a little weird. But here's what we're going to do. First of all, we're going to use this particular piece of information, which is called the fundamental theorem of calculus. It's one version of the fundamental theorem of calculus. And for the OU Business Calculus 2 students, you will have a question about this on your test where you have to write down, it says state the fundamental theorem of calculus, and you would say the antiderivative from some number to some number, a and b are placeholders for numbers, of a rate of change function is the anti-derived function with the value of b plugged in minus the anti-derived function with the value of a plugged in. And once you do this math, it will spit out a number. So we're going to use this example right here that says the rate of change of the population of Norman is given by some function here, some equation, 1,000 people per month, X months since May 2017. And we want to find and interpret the change in the population between May and October. Okay, it's really important to notice that when we go back to the idea of my calculus ladder, which I have been talking about since day one, there's my ladder. It has 3 rungs, aren't I the artist? If this is the function, f of x, that tells us in what month how many people there were, then the derivative is the rate of change, and that tells us how that population is changing per month in a certain month. It's very, very important to understand that this function is starting you out on this rung. And so you're trying to assess this concept of accumulated change, not accumulated population necessarily, but accumulated change. Okay, so let's talk about this little graph down here. I'm trying to cover up the work that I've already done. So this particular graph right here, they've graphed that given function for us. This is the rate of change function. And if it wants us to know how the population changed from May, which is time 0, to October, well, that's going to be May, June, July, August, September, October. So we're trying to figure out what is the accumulated change in this function from that left wall to this right wall. And remember, this is the rate of change function. I can't say it enough. And so what that means is this portion of the graph is under the x-axis, which means when we antiderive it, this value, just from here to here, if we only evaluated this from 0 to 2, that number would come out to be negative, and it would mean that the population decreased. And that's fine. That's totally acceptable. And then from month 2 to month 5, that part of the curve is above the x-axis, and if the rate of change is above the x-axis, the parent function, going back to Calc 1, the parent function is increasing. Okay, so there's a big difference between finding and interpreting change in some function and finding and interpreting area, which is what I'll do in the next video. So we're going to use the same example in the next video, but that's where we're going to bring in that big magic word area. Okay, so in order to assess this change, the overall change, from here to here it means the population of Norman was decreasing, and then from here to here the population of Norman was increasing. So we're trying to figure out overall how much did it change. We lost some people, we gained some people, so if we add those together, a loss and a gain, what do we wind up with? Okay, this is very important. I'll show you how to do it the by hand way, and then I'll show you how to do it the calculator method, because the calculator will do this particular calculation for you, but you got to know what's going on. Okay, so first of all, we set up and we understand that accumulated change means antiderivative. There's my squiggle. From May is 0, to October, October's 5 months later, and we're going to antiderive the given equation with respect to x. The squiggle and the dx always appear together. They're a team. They're the drill sergeants that are commanding the soldiers to do something. What are they telling them to do? They're telling them to antiderive, to find the integral. So this is equal to, and we evaluate this one term at a time, the antiderivative of x squared. Well, that's a variable raised to a number, so that's what I call the reverse drop and flop. Add 1 to the existing exponent, 2 plus 1 is 3, divide by that new exponent. Then we come to the next one. Minus sign comes along. The antiderivative of 4 is a constant. The antiderivative of a constant gains a variable. So the antiderivative of 4 is 4x. Now, we do not put plus c. The integrand, this is a definite integral. The integrand is not naked. It does not need clothes. You're not going to give it clothes. You're going to dress it up in what it has. And the way you mathematically represent that is you put this straight line. That number carries to the bottom. That number carries to the top. So now we're ready to employ this portion of the fundamental theorem of calculus. We have found the antiderivative. We have found capital F. That's this guy. So now we have to mathematically plug in the top number, do the calculation, plug in the bottom number, do the calculation, and subtract those. So I'm going to take this 5 and plug it in to this equation wherever I see an x. All right, 5, there's an x. 5 cubed over 3 minus 4 times 5. That's this part. That's f of b. Then you put a big fat minus sign. Hello. And then since we're subtracting, I'm going to put the next piece in parentheses, so in case I have to distribute a negative, I remind myself to do that. And we come back to this, the original guy, and we do the same activity, we just plug in a different number. 0 goes in for x, 0 goes in for x. So that gives me 0 cubed over 3 minus 4 times 0. And then you do your math. This is just numbers. It's not scary anymore. It's algebra 1. 5 cubed is 125 over 3 minus 20 minus, and this whole thing turns into 0. So that just goes away. And 125 thirds minus 20, you can use your calculator, you can get a common denominator, you can do it however you want, but it comes out to be 21.67. So that is the by hand method of evaluating a definite integral. So we just found, if I antiderive this equation from here to here, I get a number, and there's the number, and now I have to say what that number means. This is the interpret portion. So here is a little skeleton that you will want to use. If you'll memorize this little skeleton, it's how you're going to interpret any definite integral. First, you have to describe what those walls mean, what these numbers mean in terms of the actual problem. So you're going to say from A to B, from left wall to right wall, the output variable, what you're measuring, either increased or decreased, because it either went up or it went down. Positive number went up, negative number went down. Could be 0, which means it didn't change, but you're going to get a positive or a negative number. And then you state the calculated value, and then you put output units. It's a little 5-point skeleton. So for the terms of this problem, from A to B means, well, A is 0, and that represents May. And B is 5, and that represents 5 months later, so that's October. So in terms of the problem, these numbers mean from May to October. And then we say the output variable. What's the output variable? Well, we're measuring the population of Norman. So from May to October, the population of Norman, this is a positive number, so we say it increased by, now we do the calculated value, we write down that number, 21.67, 1,000 people. Not 1,000 people per year. We started on the rate of change rung, and we walked up one rung. And so this tells me the rate of change. This just tells me how many people are there. So when you go up the calculus ladder, you drop the per. Rate of change is output units per input unit. Regular function is just output units. That's really critical to understand, to grasp, to practice. So that is evaluate and interpret a definite integral. My next video will focus specifically on same example, but the changes that we have to make if we want to evaluate area. Study, study, so Mr. A will be your buddy.